And the first presentation is dedicated to the experience of application of small satellite Aist-2D. This is one of the new means of using small spacecraft or constellations made up of small spacecraft. And Mr. Aleksandr Fedoseev, head of the sector of Space Rocket Center Progress Russia, will make the report. Hello, dear colleagues. For you to understand, I come from Samara Rocket Center Progress, which is part of State Corporation Roscosmos. Our company has two main production directions and development. That would be the actual satellite construction and carrier units. Now all piloted launches are done with our rocket launchers. In the first presentation made by Mr. Zaichko, he mentioned also Resource P constellation made up of three craft that were made by our company too. Aist-2D is the experimental spacecraft, is a demo unit. It is an initiative of our company, and it was launched on 28th of April this year during the first launch campaign from the new launch pad Vostochny, again using our rocket Space 2 jointly with the spacecraft Lomonosov manufactured by VNIEM. We are the main designers and developers and the operators of this unit. We're controlling it and processing data acquired from this spacecraft, and later on, if the project develops further, we have plans to provide this information to customers. The main objectives of this project included demonstration of new technical solutions, development and certification of special equipment, of the payload equipment, software, as well as development of methods of acquisition and image processing and thermal imagery processing. Also, we have plans to make a number of scientific experiments, and here we cooperate closely with our Samara University, who are the developers of the whole scientific payload, and the whole design and development process is combined with the training process, and jointly with the university we trained specialists for our rocket and satellite industry. This is what this satellite looks like. Its characteristics and specs can be seen on the next page. First, I will tell you about the payload acquisition equipment, and then about the scientific payload. The satellite was launched to the solar synchronic panel, orbit. The ground resolution at the moment, which is confirmed, is no worse than 2.5 meters in panchromatic mode, and about 6 meters, no worse than 6 meter resolution in multispectral mode, 3 spectral resolution of visual bands. Also, we have a mode of acquisition in thermal and infrared band with pixel projection 122 meter and a swath of about 55 kilometers. swath width of the acquisition equipment of the visual band of spectrum is almost 40 kilometers. The speed of data transition 50 megabit per second, and the active life cycle planned for this satellite is 3 years. It weighs a bit less than 450 kilograms. I'd like to mention that a number of characteristics and requirements for this satellite at the stage of its design and development were not mentioned here, but during the flight tests, and the flight tests are still ongoing until at least the end of this year, we found out that these characteristics can be measured and formulated with even some designated borderlines, and then put into the spec list of our satellite. Payload equipment, then optical equipment of the visual band, which consists of optical mechanical unit and optical electronic unit with optical electronic converters. It can do multispectral and panchromatic acquisition in visual band with the resolution of no less than 2.5 meter and 6 meter respectively from 490 kilometers, and it is based on the symmetric mirror lens with the maximum angle of view and minimal weight and dimension characteristics. It consists of 2 units. First is the mirror lens, which consists of the body itself, the main optical unit, and additional unit, and the also a forced focus adjuster and a focal unit. Then the optical electronic equipment consists of optical electronic converters for panchromatic band and multispectral mode. Then the power source, optical electronic IR band, onboard memory bank, and transmission device. When acquiring in thermal infrared band, they will also do experimentation on how to apply special microbolometric receivers, which we understand in future can be mounted on small satellites because they do not require cooling. And with the use of this equipment of thermal IR band, we'll try to also detect small fires, which is very relevant for our country now. Now a few words about the scientific payload mounted on this small Aist-2D. That would be spectrometric weight sensor IMS-1, which was developed, and the main purpose of that experiment was to study the influence of factors of space environment on the hardware elements of the satellite. Sensor of DG particles sensor, which is developed for experiments related to studying of degradation of elements and optical elements of the payload and degradation of under the influence of space environment. Meteor M equipment was developed to measure characteristics of the influence of micrometeorites and small particles which are flying in the near Earth space. And we are studying micro acceleration phenomenon. We use it for potential future use in small satellite construction, and also two scientific equipments. One is a combined specialized equipment to study the fiber optic sensors. This slide shows the cooperation in the development of this spacecraft. It's a bit different from the cooperation that we used to use when building satellites upon the request from Roscosmos. The ground-based infrastructure. The ground-based infrastructure is represented here by ground transmission, reception, and control of the spacecraft. First, it includes the ground-based spacecraft control system, which is a complex of radiotechnical complex for the reception of data, then data processing center with a full cycle of data processing, starting from the restoration and ending with the standardized product delivery. The concept here implies that to process information acquired from large satellites like Resource P, we work with this and the complex of storage and information interaction when storing the information, and the center to use scientific equipment. That's how they're interlinked with each other, and that's how they will interact with the external stakeholders, like university, for instance, Samara University in our case. Despite the fact that now we continue to do the flight trials, during these flight trials we have tried to use this information, and the pilot platform for us was the Samara region. A number of these thematic objectives are being addressed already at the regional level. For instance, such very relevant objectives for us as detection of illegal extraction of deposits, a place where the people dispose of their solid waste. Also, we are actively cooperating with the Federal Ministry of Emergencies
in locating fire hotspots. This is Ninets autonomous district, and these are image examples. They've been taken prior to this conference. Visually, images look great. They have very good quality. And this is Agra, the venue of this conference. Image taken on October 20th this year. In conclusion, I would like to say that at the moment, flight tests are held to overcome restrictions embedded before. So we are in the process of identifying the finalized characteristics, and we try to find potential uses for this information. We're looking at 45 degrees, turning in roll by 45 degrees. Together with interested organizations, we're looking at how it can be used. I mean, Ministry of Emergencies, Ministry of Agriculture, regional authorities, and some profit-seeking entities. And in conclusion, a couple of slides about way forward for this project. First of all, we plan to develop this project as a low mass dimension space platform that can carry different equipment depending on the purpose of the mission. So it could be research equipment, modernized high-resolution equipment, and innovative hyperspectral wide swath or wide-angle equipment. So configurations may vary based on Aist-2D. We're talking with 35 meter swath, 2 upgraded Auroras with swath width of 40 kilometers and spatial resolution of about 1.5 meters, and a satellite for mapping with 2 Auroras and LiDAR also as a project. That's all I have. Thank you for your attention. Thank you for your report and for being on time with the schedule. Ilya Yudin, Digital Globe. Do you have any ideas as to how you can sell this data at a cost? I mean, we do have some ideas to make profit off of that. We're working on a business plan development, and we're open to cooperation with potentially interested distributors, operators, as far as cooperation, commercial cooperation is concerned, to build a line of smaller satellites. Following up on this point, you said that this is an initiative product, design product. Does that mean you have the rights to it? Yes, we have registered our rights this year. It's our property, so we can buy data from you. Yes, if we agree on being able to sell the data, then we're the ones to sell the data, that's for sure. Well, I guess that's it. Thank you very much once again.